Hi everyone, this is question number 12 in chapter 2. So we need to find the differentiation for each of the following functions by using the quotient rules. So it's just like the product rules. The quotient rules can be used when we find that y is written in a form of u over v, whereby u, v, they are the function in x. So to find the differentiation, dy dx, okay, always differentiate the u first. So stay v, do u, minus this time, stay u, do v. Okay, and then over v squared, or in short, just write v, u prime, minus u, v prime, over v squared. So just use this. Okay, therefore, now, just like the product rules, after we have differentiate, we should factorize it. I mean, we need to factorize. So if we can factorize right from the start, let's factorize it to make things much easier. So this one can't be factorized. So we mark this down. This is u and v. And therefore, the dy by dx will be stay v and do u. Differentiate u, that is 1, and then minus stay u and do v, that is 2, and over the v squared, so 2x plus 1 squared. All right, expand the expression. So we have 2x plus 1 minus, multiply this in, minus 2x plus 4. And then over 2x plus 1 squared. So the answer will be 5 over 2x plus 1 squared. That's it. Okay, as for b, just do here, b, this is u and this is v. As I said, if we can factorize it first, please do it to make our job easier. So y, we have x squared plus 3x minus 4. So we factorize that right away. So we have x, x minus 1. So we have one of the factors x minus 1. So x plus 4, right? Okay, only when we see that we can factorize it, we can simplify it with factorize. Otherwise, we just leave it. Okay, we just leave it. So over here, that will be x plus 4. But the question already give a very clear instruction that we need to use the quotient rule. Therefore, we can't do this one. All right, so forget about that. But if the question never specifically mentioned which method, we should factorize it to make things much easier. And we can check if we get the same answer. So after we factorize, we get x plus 4. Therefore, the dy by dx, we will get 1. Okay, so just remember this. This is not the solution for the dy dx here because we are supposed to use the quotient rule. So we have to use that. And therefore, the dy dx will be stay v and differentiate the u. The u is 2x plus 3. And then minus stay u, which is x squared plus 3x minus 4. And differentiate the v, which is 1. And over the v squared. So x minus 1 squared. Next, we expand. Okay, we expand the bracket, this first part. So when we expand it, we will have 2x squared plus 3x. And then we have minus 2x minus 3. Open up this bracket. So we have minus x squared minus 3x plus 4 over x minus 1 squared. Okay, let's see what can we do. So 2x squared minus x squared. So we have 1x squared. Next, look for the terms with x. So we have plus 3x here and minus 3x. So they cancel off each other. We're left with just minus 2x. Next, the constant, negative 3 plus 4, we're left with just 1 over. Now, at the same time, I actually can see that this is actually the, we can factorize it to x minus 1 squared. So I expand this. So x squared minus 2x plus 1. Can you see that? They're actually the same. So the whole thing you can simplify, left with 1. Therefore, your dy dx is 1. So isn't it the same as we factorize first? Then only we differentiate? Always factorize so to make things easier. But over here, we can't because the instruction is clear. It wants us to use the quotient rules. So we can't use the factorization method. All right, now next. All right, this is u and this is v. Therefore, dy by dx. Let me change to this. Stay v, 2x minus 1 squared. Do u, we have 3x squared, minus stay u, and do v. That is 2x minus 1 raised up to the power 1. 2 minus 1 is 1. And continue the inside. So we have 2 over 2x minus 1 when we originally square and we square again. So we have power of 4. And next, you notice that 2x minus 1 and 2x minus 1 here, the highest power is, the highest common factor is 2x minus 1 power 1. Anything else that we can factorize? The x squared. Let's just factorize the x squared. Now, take out. So we take out the x squared and 2x minus 1. And therefore, the first term, we have taken out one of this, so left with 2x minus 1. And we have taken out the x squared, so we're left with 3. The second term, we have taken out the x squared, left with 1x, yeah? So the 2 and the 2 here, we multiply by 4, so 4x. And then the 2x minus 1 already factorized, so that's all. That is what we left in the square bracket. So 2x minus 1 raised up to the power of 4. And do you notice that 2x minus 1 and the 2x minus 1 here can be simplified? One of them, so left with 3, power 3. So on the other hand, the inside in the square bracket, okay, we expand it. So we have 6x minus 3 minus 4x over 2x minus 1 raised up to the power of 3. Okay, therefore, the dy dx, simplify, x squared, 6x minus 4x, we're left with 2x minus 3 over 2x minus 1 raised up to the power of 3. Okay, that's it for question number 12.